So here you can see, so it will allow only certain selective frequencies and attenuate or stop the rest of them. So that is the purpose of the electronic filters in electronics. And if you talk about filters classifications, generally we can classify the filters into two types. One is a digital filter, another one is called analog filters. Digital filter means mostly digital filters are implemented using digital computer hardware together with certain software tool. For example, in MATLAB, you can also do some analysis of IIR filters and FIR filters. These are called digital filters. So you can also see the digital response, the frequency response using these digital filters. So where do we use these digital filters? In some processors, microprocessors, we are also using these digital filters inside. Or these digital filters are implemented in some special purpose digital hardware. Okay, so in general, these filters means here it's a digital filters are just a computational process, or it's based on certain algorithms. So what these algorithms are doing, it converts one sequence of numbers representing the input signal into another sequence of numbers representing the output signal. So that is how the digital filters are working. So because everything is handled in terms of numbers, the signals, because digital means what? Everything you are going to handle in terms of digital, right? Bits, zeros and ones. So whatever the numbers we are converting in terms of bits, and then we process them, and then we arrange them in certain sequence at the output, and then we convert into whatever the form we want. If you want to see in terms of digital number, decimal numbers, you can see that at the output. Or if you want to see as a frequency response as a graph, you can also see that. So everything can be implemented by using software. So that is what I mentioned here. So we have a digital computer together with certain software tool, we can implement these digital filters. So you will study about the digital filters most probably in your signal processing course, digital signal processing, DSP. So in this course, electronics, you will only study about analog filters. Okay, so therefore a digital filter can perform functions as differentiation, integration, estimation, and so on. It can also filter out unwanted bands of frequency. So it can also perform like filtration operation. The signal frequencies, you can get selective signal frequencies at the output. So, but it's really depending upon the application where you are going to use. You can select which filter you want to implement. But generally, this is what digital filter is. Analog filters. Analog filters are used to filter out unwanted bands of frequency. So that you know now the meaning of what is this unwanted bands of frequency. So it's really depends on the application. So if you want to give only low frequencies, or if you want to give only high frequencies, or if you want to give only a specific bands of frequency, or if you want to stop a specific bands of frequency, then you can use analog filters also. So analog filters are classified into analog passive and analog active filters. Before that, I will show you this one. This is the overall classification flowchart. So all the signal filters can be classified into two major types. One is analog filter, another one is digital filter. So we had seen what is digital filter, and digital filter also functions same as analog filter. So in addition to the filter function, it can also perform some other operations like a differentiation, integration. I have already showed you here just before. So differentiation, integration, estimation, and so on. Okay, so this is not our focus here in this course. So we will talk about only analog filters. So analog filters can be classified into two major types, which are element type and frequency band. Element type means what? So what kind of devices, components, electronic components you are using to implement the circuit. So based on that, we can, so if you are based on that, you can also classify into two types. This one element type. So element means that is the electronic devices. So there are active elements and passive elements in electronics that you may already know about that, or if you did not know, just I remind you now. So what are the passive elements? Or LC. R means resistor, L means inductor, C means capacitor. And active elements means all the transistors and operational amplifiers. So we call this as a active elements because it can also act as an energy source. It can change the input signal at the output. So we can use these active elements in the filter design, then it's called active filters. You can use this only these passive components in the filter design, then that is called passive filters. So remember, based on the what type of component or device we are using, that is why this is called, generally these active and passive filters are called as a element type analog filters. Okay, another one is called frequency band. Frequency band, based on the frequency band we can classify. That is what low pass filter, because it's passing only low frequencies. And because you remember the low frequencies means that is certain frequency band. And similarly high pass filter, so it passes only high frequency signals. And band pass filter, it passes only certain range of frequencies. And band reject filter or band stop filter, so it eliminates certain frequency range and then allow all other frequencies, just the opposite operation of band pass. All pass filter means it passes all the frequencies, but it gives a phase shift. So for example, in the input, if you apply a signal like this, at the output, you will get 180-degree phase shift. So you remember in operational amplifier, in the inverting amplifier, if you give the input to the negative input terminal, what's happening at the output? So here you have plus VSAT, minus VSAT. Here we have the output. So here maybe you can ground this terminal, positive input terminal. And then here you are giving the input like this. At the output, you are getting 180-degree phase shift. So some kind of filters perform the kind of similar kind of operations. We will see the detail later when we discuss about the filters. Okay, mostly we will use this kind of all pass filters in oscillator design. So now you know that analog filters can be classified as the element based or frequency based. Element based is active and passive, and frequency based can be classified as low pass, high pass, band pass, band stop, and all pass. Okay, so of course in practical we are just combining this and this. So we call this active low pass filter. If we design this low pass filter by using these active components, and we also call this as a passive low pass filter if we design this low pass filter by using these passive components like RLC. When we talk about active, we are all using these transistor operational amplifiers, for example, together with passive components.